Alright, so let's start from where we left off. So as I was saying, what if we just want to, divide the ID with the 2, and if the remainder comes with the 0, then we'll assign a color red, and for those particles having the ID giving the remainder of 1, if they are getting divided by the 2, then we'll assign a color green. So let's do this thing. So let's see how do we going to prepare this statement, how are we going to prepare the text or the expressions to deal with this kind of situation. So let's do one thing. Let's press Ctrl A and move back to the RGBPP, go to the create expressions, and let's say if we are now inside the creation mode. So let's say if I have if particle ID, that is the particle I capital D. So we cannot show the process that we divide the ID with the 2, so we can simply write down the modulus. So modulus will give you the remainder, the result. So if the particle ID is modulus 2 equals to the 0, then we have a condition. Let's say nParticle shape 1 dot RGBPP equals to 1, 0, 1. Alright, and let's close this condition. Now the particle ID modulus 2 equals to the 0. That means, let's suppose we have a particle ID of, let's say, 10. So 10 divided by 2 will give you the remainder 0, because 2 5s are 10. Alright, if we multiply 2 with a 5, we get the value 10. That's a complete value. 10 under 10 will give you the result 0. And let's say just copy this, and we can also put it over here, paste this and create. Alright, now if we change the shading type from numeric to the sphere, and let me just roll back the timeline. Alright, so I have actually entered 1 0 by 1. So let's say I just get rid of this and hit the edit. Now inside the runtime before dynamics also, let's delete it and put that into the 0. So now we have the red color, and now if we play, you can see we have the particles with the red color. Now you must be thinking that why the cyan color is coming, because we don't have any conditions for those particles whose ID, or you can say the modulus, is not equals to the 0. So let's do one thing. Let's go over here, and let's say we are inside the creation mode only. Let's Control A, Control C, hit the enter and paste the entire expression. Now let's say we have the particle shape 1, particle ID modulus 2. If it equals to, let's say, 1, that means if the remainder is 1, then in that case we have a green color. Alright, and similarly we can make it to, we can write some further more expressions, like if we press Control V, just copy the entire expression again, and let's say we have the modulus 3. If that's equals to the 0, then in that case we have a blue color. That's okay. And what if in case we have the ID modulus 3, if it's equals to the 1, then we have the combination of the green and the blue, that means the magenta. Alright, or let's say we already have a magenta, which is the default, so it might can create a confusion. So let's say we just give a white color, and that can be possible if we write everything with 1 1 1. Alright, so we can simply copy this, just clear this and paste this and edit. Perfect. So now if we play the timeline, you can see we have much better control, and we can clearly see that the red particles, if I select them and if I take you to the numeric mode, then this value should have some even number, only then it will give the remainder 0. So if we go to the numeric mode, you can see it is 158, so it can be easily divided by the 2, and the resulting value will obviously going to be the 0. And in this case where we have 131, so in this case what should be the particle color? It cannot be the red, one thing is sure. If we go here, we have the green color. And what's the condition for the green? The condition for the green is this: if the ID is not equals to the 0, or we have the remainder 1, then we have the color, green. All right, and other colors are also based upon the expressions. So this is how we can actually control the overall color, and we can actually control the broader section of our particles. And this is not even just limited to the scope of changing the color. We can do even something more. Let's say if the particle has its speed which is more than, let's say, 10 or 15, then those particles should die out immediately. So how are we going to do that? Well, that's pretty straightforward. First, we are required to generate our own customized per particle attribute. So for that, we need to go over here. Let's say we go to the general and change the attribute type to the per particle. Let's say we want to give the data type as a float, and let's say we have capital M my underscore speed, and hit the option OK. And if we just refresh this, you can see we have the lifespan, we have the my speed over here. All right, so let's go over here and let's say now we want to query this for the entire frame. So we can just start typing in the creation, and then we'll take this inside the runtime before dynamics. So let's say, what if we have a condition in which the n particle shape 1 dot speed equals to the magnitude of the velocity. Now mag is the function that will going to return you the magnitude of the vector value. So since we are going to use the velocity, so velocity is a vector value, so we want to take out the magnitude of that vector field, or the velocity. So we can use the mag, and over here we can have the n particle shape 1 dot velocity. All right, and make sure that we have typed correctly. Hit the edit, and we can just simply copy this, go over here and just paste this, and hit the option edit, and make sure we don't have any errors. That's great. Now let's do one thing. Let's go inside the particle render type, change the sphere to the numeric, and instead of the ID, let's change to the my underscore speed. And notice what we have. We have the values of the speed. So if I just roll it back, and let me also just reduce the overall particle count. Let me take the 10 just for the visualization purpose, and let's also increase the speed to maybe, let's say, 20 units. And now if we play, you can see there's a point where the gravity is totally affecting the particles, and the energy is converting into potential energy, and now the speed is getting reduced. This is also just because of the drag we have as well as the gravity. So over here we have the value of, let's say 3. So if the particle speed touches the value of 3, then particle should die instantly. That is the condition we want to create. So it can be possible if we go inside the my speed, and inside the runtime before dynamics, let's give a condition if speed is less than 3.5. So in this case we have n particle shape 1 dot lifespan pp equals to -1. So it simply means that the moment it goes below the value of 3.5, then particle will die out instantly, because now we are actually utilizing the lifespan per particle. All right, hit the option edit and make sure we don't have any errors. And now let's go back to the shading mode with the type as a sphere. And now if we play the timeline, you'll see nothing is actually happening. Well, this is pretty much clear and straightforward, because most of the time even I do the same mistake. And the mistake is that we haven't changed the lifespan, which is set to the lifespan mode live forever. So we have to change this. Now notice we have the data type, we have the particle render type numeric. Over here we have the value 2.65. But whereas in our expressions we define clearly if the speed values go beyond, or let's say if it goes less than 3.5, then particle should die. So all these particles with the value less than 3.5 should die immediately, but they are not. This is just because of the lifespan mode set to live forever. So change this to the lifespan PP only. And now if we go back to the sphere, so right now you can notice we have the particle count somewhere on 39 at frame 97. Now if I play the timeline, you'll see the particles are started dying instantly, and I'm at frame 114 and we still have the particle count to the maximum 15, because now the particles which are having the speed below 3.5 are actually dying. So this is also another good method of controlling your particle expressions. So let me just take you back to the overall expressions. What do we have? And let me just increase the size. So this is actually the condition. All right. So I hope so, guys, you must have understood this concept. Now let's take a pause and move to the next clip where we talk about the position of the particles.